Today we have a financial planner app that I've been working on, and it is architected in using domain-driven design as the methodology. So it has a pretty clean architecture. And today we're going to talk about mapping domain models from data entities using Entity Framework as the backing ORM with SQL Server as a database. So very typical setup for a piece of software. And this diagram that I created is a sequence of what a typical repository method would look like. So we have a caller who basically calls some method to get some entities from the repository. You have some kind of link expression passed off to Entity Framework, translates that into a SQL query, executes that in the DBMS. We get some rows back. EF serializes, deserializes that data, returns back some data entities, and then the quote unquote problem that remains unsolved is the need to map those data entities back to domain models. And so this is effectively a read model or read operation. And mapping is kind of a simple concept, but also context to domain-driven design can be quite complicated depending on how you do it. And so there's things out there we can go look at. Whether we, so if we go domain, let's actually do map domain entity to EF, for example, and there's some different ways people are doing this out there. So of course, it's pretty typical for people to build some kind of base repository class. No problems there. If you use Entity Framework, it can map to a rich domain model itself. So technically that's true because you can map using EF Core has much better mapping capabilities than EF6 even had. But I'm in the camp that your data model, so your EF models, should not be used as your domain model. And if your domain model is simple enough where there's no difference between your domain model and your data model, then I would argue that maybe something like domain-driven design is overkill. So for me, I want my data model, my data entities, my POCOs to 100% match my database schema because I'm going to have query scenarios that exist outside the domain model. And I want that data model to be easily maintained side by side with my actual database schema. I don't want there to be problems. And the database schema is also going to be managed, at least in my case. I love using these SQL Server database projects to actually manage the schema. And typically, I will actually write scripts that are sequenced using transactions and some kind of mechanism to handle upgrades of the databases. So taking EF and using that to map directly to domain models, to me, is a architectural no-no, because then you basically end up sharing this common model library across all your different layers, whether you use it kind of like a horizontal architecture or vertical sliced architecture, doesn't matter. I want these to basically match a database schema. That's what they need to do. Using EF models already solves a huge problem of not having to write lots of T-SQL and all that. So why try and turn it into something much more than that? And example of this, we go look at our domain model here. In this project, we have a little financial app all pulled up. So we have the ability to add some income. We can, let's go and click add. We can specify if it's income, expense, asset, investment. We can name it. We can give it an amount. We can give it a date. We can indicate if it's a recurring transaction, although I don't know why that's not running at the moment. Let's refresh this actually. And there we go. So we have like a occurs once transaction. We can have, end day of the month, weeks. And so like I can set up, okay, there's my paychecks and all that. And so if you think about the domain model here, we have a user that logs into the system is a person, and a person has income and expenses, assets, investments, and transactions. So in this very simple app, person is basically the aggregate root, and transactions are domain entities that are managed by that aggregate root. So we have that modeled here. We have person. They have things like, I don't have the basic stuff on here, like name and all that, but net income, expenses. We get down here to transaction, date, name, amount is expired, meaning maybe a transaction it occurred on a date in the past. And then, there's an occurrence, it can occur again. And then maybe there's an end date, and then there's a time unit. So person being the aggregate has one person to many transactions. And then we're not doing the relationships from the perspective of a database. So in this case, one transaction has one occurrence, and one occurrence has one time unit. So that's the domain model. So it's not a anemic domain model. It's not a flat domain model. It's an aggregate root. And if we go look at that in the actual project itself, we can see that person is not anemic. So we have all those properties with that information, but we also have actual domain logic. So it's a rich domain model. And while most of this domain logic are methods, so you could argue, yes, I can map these from EF models directly, or from EF rather, and map directly to my domain models. It's not a good idea because this person class, this aggregate root, may not look like the data storage structure, aka database schema, and it's going to need to evolve over time in a manner that is going to be different than the evolution of the database. So often both evolve at the same time because obviously you have to be able to store data for your domain model, and there's going to be typically a close match. But if you are doing domain-driven design, you've done it for a long time, you'll find that eventually your domain model often looks different data model, especially in different bounded contexts. If you have a vertical architecture and you have different like modules of your system, and you have different like person classes that look different, and see how that design of the domain model changes from how the data is actually stored. And then there's things like optimizations on the database side that won't exist on domain model, vice versa. So anyway, so that's the camp that I live in. So the data model is 100% separate from the model. So going back to look at kind of the problem that we're going to code is how to map these guys. A lot of different ways we could do it. There's auto mappers as libraries. You could use EF if that fits your use case. I typically don't like to use third-party libraries. I typically like to have all my code as my own. And even in the organization that I work for, that's kind of the same general philosophy because you want to basically have your own, what do they call it? Proprietary assets, So anyway, so we're going to go down to the mapping phase. And so, again, we kind of went through that sequence. We go down to the mapping sequence. So we have caller, goes to get some entities. We get those data entities. That's the sequence diagram we just showed up above. And then we need to effectively have like some kind of aggregate root. Typically, we're going to map the children first because those children are going to probably get injected into the aggregate root through a constructor. If those, like let's say the collection is IEnumerable and it's immutable from the outside world, then it's going to go in the constructor. And so we're going to map the children first, and those are going to probably get injected inward. So we're going to, if we have child model A, child model B, so map, get those back, map child model B, get those back, and then finally map the top level aggregate root, get that back, and then at the end of the day, we're going to return the collection of domain models from the repository. And so as you can see, we already have all this going on, and a repository is effectively a data storage abstraction, but also a mapper and also a factory class, right? Because it's not only retrieving data entities using some mechanism, could even just be plain SQL or ADO, ADO.NET, EF could be in Hibernate as the mechanism, but then it also has the mapping responsibility and the factory responsibility to actually create domain via that mapping. and return that back. So repositories kind of have this, I suppose, single responsibility at a high level to retrieve domain. But within that one high level concept, they have quite a lot of responsibility. So we want to break that down into a smaller problem. So we're going to go look at what I have here. So in this current app, I effectively have in the data layer, and I'll do another video to talk about my my thoughts on where repositories lives. But in this project, they live in the data layer. These are data repositories, so they're coupled to the entity framework context on which they operate. And if we look at the design of a repository class, let's look at, let's see, DB repository. Obviously, it takes a context. So these are designed still around a unit of work. So the repo does not actually make calls to save changes. It can read, but it leaves that up to the caller so they can determine when they're done with the work. Because you might want to be able to use multiple repositories together to make a bunch of changes as part of the same unit work, and then ultimately call save changes on the EF context. And then we have query, is really a queryable expression. And so this was something I came up with that was really cool. Basically, we want to be very optimal in what we're loading from the database. So we don't do lazy loading. We do only eager loading. And basically, if we go look at a particular repository, like person repository, we can see the query expression for that is, okay, we're going to go grab from the users table. We're going to include their transactions, and then we're going to include the transaction type, and then we're going to include the transaction occurrence, and so on and so forth. So this produces a very specific SQL query where everything's loaded with one at query instead of entity framework firing off lazy loaded queries as soon as we start accessing navigation properties, which is really important when we start talking about profiling the execution of these repository classes to make sure that they are fast with high volumes of data, many, many rows. They don't take up a lot of memory. You know, all these concerns that we need to be thinking about when we design these repository classes. And so going back to effectively repositories having a single responsibility, kind of, sort of, right? You can tell there's a lot going on. I'm going to ignore these and skip over those for the time being. There are circumstances where we need to load additional data from the database to do something. And that is something that a repository can encapsulate. And so that's what these are doing, is like, these are lookup tables effectively that exist in the database. So they are the single point of data integrity in the system. And so we have some lookup tables that actually define the named transaction types, the named transaction occurrences, transaction occurrence. There's probably I don't remember if I put time unit in here. Let's see, occurrence. Yeah, we did. So there's an occurrence with the time unit. So the database is that single point of integrity. It is the master of all. And then, of course, we have query methods, find by user. Looks like the only one. And then we have the mapping. So as we get into the mapping, that's really the heart of this topic. So my first go at this was basically, hey, repository is the factory, it's the abstraction, it's kind of everything. And it's not a lot of code, you know, it's 192, but you can see how very quickly this gets very messy, because not only does the repository need to define these query methods, but you toss in the mapping in there, it's just a lot. And then it also becomes a lot to unit test as well. And having this all in the same class makes them pretty difficult to unit test, especially when in your unit test, you have to set up mocks for entity framework and mock out the context and set up a DB set and do this and do that. It's quite hard to test these, especially when you start including child entities into the mix. And so we want to do is make this very testable. I'm not going to cover the unit tests themselves as we kind of go through this, but our goal is to probably do two things. One, we want to strip out the mapping piece into its own concern. And two, we want to take this kind of code. So again, person is an aggregate root, which means that that aggregate root is responsible for the lifecycle of the children entities in which it contains. It's responsible for how they get added. It's responsible for the changes. It's responsible for their deletions. That's kind of the whole point of an aggregate, right? Is it maintains the integrity of everything within that boundary. And the problem with that is it can become quite challenging as we have to write like an update method, say, to update the aggregate. It's like, okay, well, not only do we have to update the person itself, maybe we have to change the name, update the email, whatever. And this is just data persistence at this point. This is not domain logic, right? So we're basically, the domain logic was already done. So when we take this person class into the update method, if we assume that the person class is in a valid state, because that's kind of the fundamental rule of a domain entity, is a domain entity should never be in an invalid state, right? There are invalid states a domain entity could be in, but let's say by design, right? So let's say like a person generally has to have an email, and you would say, okay, well, email is required in the system. Okay, great. But is there a scenario where they can sign up for your piece of software and not provide an email by default? And what happens in that case? So there's these cases where not having an email could be technically invalid, but maybe the idea of the absence of an email is integral to the way you've designed the system. Like, that's okay. And in that case, it's a mutable field, right? But everything else around that, like if you actually have required fields that must always be there, that would already be taken care of by the domain objects. When we get here, we assume that all the data that we have that's being provided by this domain entity is in a quote unquote valid state. And so at the repository layer, we don't care necessarily about logical checks, say, if email's there or it's not, and so on and so forth. We are simply concerned about mapping persistence. And so in this particular method, we are not updating anything about the person. As we can see, we basically are just really taking care of the adding, modifications, and removal of the transactions which that person owns. Okay. And so this is very messy code to write. So we have transaction as one child entity, right? And for that one thing, we have to have 3 logical flows, one for adds, one for modifieds, one for deletes, to take care of that. So if we were to add additional child entities into the aggregate root, not only does it become a more complex aggregate root, but then we have to write a lot more repository code, sorry. So 2 goals. One, strip out the mapping so we can kind of isolate mapping on its own, because mapping is just this idea of object A converts to object B converts back to object A. That's the only problem that mapping should solve. And then we have this problem of actually managing the life cycle on the entity framework context, and that's a separate issue. And we're going to try and abstract that out and do some voodoo magic. And we're going to do that pretty much through navigation properties. And so this code should refactor out. And so we're going to go ahead and try and do this. And we're going to design some kind of mapping mechanism and maybe explore a couple different ways to go about that. So we have some mapping methods. So when we talk about mapping, we have a read scenario and we have a write scenario. And so we're going to go down to our data layer, and we're going to start. I'm going to actually start up here. I'll move it into a file later, but kind of have this idea of something that's like a data entity map. Okay. And so we know that, some type of object is going to be the principal type of object. So if, given that this is a architecture that facilitates domain-driven design, or the domain model is isolated, and the domain model is kind of the focal point of the software, we can say that domain model is kind of like maybe the principal type. And so we could say like T, let's call it like, I don't know, T domain entity. And then we could say T data entity, right? So we want to map a domain entity from a data entity. A to B, B to A. Maybe that's kind of the idea, right? So maybe that's what our mapper looks like. Now, obviously, we have a couple things we need to do. So we need to say something like, let's actually start with an interface, I suppose. Actually, I data entity map. Okay. And then let's say we need T domain entity, right? Map from data entity, the data entity, right? Data. Just to be very precise about this. And then we're also going to have something like T data entity map from main T, the domain. We got to go the other way around, right? And then there's also the scenario of like mapping from implies creating new. Okay. So I have a data entity. I want to map a domain entity from it, which means that it's going to create that. But we might have some circumstances as we write this where we're generally always going to have a domain entity. Not a domain entity, sorry, data entity, right? Because entity framework is going to read it. It's there, going to get created. And so I'm thinking there's a situation where we want to do something like map into. So it's something like map domain entity into data entity. Something like that. Right. So maybe we just call this map into data entity. We already have an existing data entity. Right? We're not creating one. So that might cover some cases. And then, of course, we're going to have the implementation of that data entity map or data entity. And let's go and implement that. The data entity. Right. Okay. Now let's say that by default, not everything supports. I guess, do we want to always say we can always map back and forth, or is it primarily one direction? We're going to start with the read, I suppose. And then we'll eventually have to tie this mapper into the repo. Okay, so let's move our interface, though, into its own file, as well as this guy, just to get those out of the way. And let's go back in our data entity map. And so if we go, we're going to take like, these probably should be abstract actually, because this is framework level code. There's not a default mapping of anything really. So this really should probably be abstract. There's a reason I'm going to make this abstract, because when we need to deal with the child entities, there might be some form of base code that we write in here, I'm thinking. But let's solve the parent level mapping first. So for now, let's make these abstract methods. We might not even need the interface if we do have an abstract base class. As well as map into the void. So then we're going to have start with person map data entity map of person, be our domain. So in this particular project, I'm putting the data layer does have a reference to the domain model, not the other way around. Okay, so you can think of this as part of the infrastructure layer in DDD, but data is infrastructure. And this all has to do with just data. So if I was to separate out like file IO and all these other things for infrastructure, might look a little bit different. And then if I was building a modular architecture, I might have like a financial planner transactions module, income module, expenses module, things like that. And then within those modules, now I would probably look at doing more vertical architecture where the layers within that module, including the domain model, would be in one library separated out that way. So for now, we're just kind of working this way. And we're going to take, obviously, a DB user, what we're actually mapping to and from in this case. Okay, so we have a person map. Okay, we're going to go to our person repository, and we're going to start with these mapping methods. So we basically have like map get entity to domain entity, and right away, probably this code here, where we start dealing with the children, we're going to move. So let's go ahead and replace transactions. Let's go ahead and copy that code, I suppose, and we'll comment it out for now. Have to put it back in there at some point. Okay, but for now, what we can do is say transactions is equal to a empty collection. Yeah. 0. Or we could do enumerable empty, I suppose. Or array empty. That's another option. Okay. So right now, that effectively would be the mapping for a person. So we're not exposing like their name or anything like that yet. Mainly just the UID. And that's something important, I guess I should show about this particular database. So we have every database table, we're using ints for the primary keys, and then every table has a UID for the GUID, which is also unique. Yeah, so we have a UQ user ID. Okay, so that effectively, quote unquote, maps a person for now. Okay, so that's the mapping from a data entity. So we create a domain entity. We'll deal with the children here in a bit. We're going to do the mapping from. So we're going to say map, whatever the hell that is. Let's see. Map. Data entity to domain entity. I feel like I was bad with the naming convention on these. I must have only done a read for person and not a create yet. Because I think the way the system, I started building this a while ago. I think the way it was is sign out. You can pick your identity provider, ignore the logo. I started this as a project for a different thing. Warpath's actually a game I play. I was building a tool. Decided instead to build a financial planning app. So I can pick the identity provider though. And I think what it does, if I remember, is it auto creates a user profile when you sign in from that identity provider. And so that's all infrastructure code. And so there's no need to map a person to a user, I don't think, is why we don't have that right now. So I think we can actually jump then straight to the children entities. It's like we had the debugger running for some reason. So let's go do that. So let's actually plug this back in. Go back to our person repo. So we have the mapping for a transaction. Now, we can do two things, I suppose. We could put all the mapping for the parent and the child in the one person map. But I know that certain aggregate roots, mappings get quite large. And again, it becomes a lot more to test. And really what we want to do is we want to piece it out so we could test the units. Okay. And this is probably a little bit counterintuitive that we're talking about unit testing without doing unit testing, but it's very easy to actually write unit testable code, knowing dependency injection and the fundamental practices around that. So what I want to do is actually say that maybe a person map has a whole other type of map And this doesn't have to do anything with the base class, but maybe we say like public virtual, and I want to be able to override this, or even set it. So it doesn't even need to be virtual, I suppose. So we can say data entity map, and we're going to say this person map has a transaction map. Okay. Like so. And yeah. Okay, so that's the name of the properties. So we're going to actually create down here a public class transaction map will be action data entity. Oh, being stupid. I'm being dumb. Carry that over. That and similar thing. And for now, I think what we're going to do is we're going to take the mapping to a data entity. We're going to rename this because this is confusing. We have map from data entity and map from domain entity. That's kind of confusing. We're going to actually rename this to map to data entity. So we have map from data entity and map to data entity. What we're going to do. We could do it the other way around based on the, we could do map from domain entity and map to domain entity, given that we basically said domain entity is kind of the principal, but now we've kind of basically said data entity is kind of more the focal point. And that's okay. But in that case, then we might swap the type parameters around later. So data entity is actually first. And I wonder if actually Visual Studio has that refactoring capability like ReSharper does. Probably not. Look at it later. Okay. And then I think what we're going to do is we're going to say that there's a default implementation for mapping to the data entity. I think we're going to say not supported by default. So we don't have to override it in every single derived class if we just need to read. Because it's more common that we're going to read from the database than persist to it in most cases. So that would also mean that we could, which one was that? Map to data entity. So we're going to actually remove that on there. Oh, and instead of the interface, we want the abstract class, right? Has to be. Okay. Good there. And that also probably applies to map into as well then. So we're probably going to, these need to be virtual so they can be overridden with the new implementation. And now we can get rid of the map into. So we're going to focus on the reads by default. So we're making the default implementation of a mapper less work. Okay. All right, and then we need a constructor for the person map that takes a, no, we don't actually. Oh, I know what we need. Because I need a get and a set. I think I have nullable turned on these projects actually, so I have to remember to be very specific that these are nullable reference types. I'm still getting used to that. I actually don't like the nullable reference type feature. You can hate me for it, just how I feel. Okay. So going back to our mapper. So we have person map. We don't really have the ability to. Yeah, we do. So basically what this would be something like select. And now we can take this call to the mapping method and we can delegate it off to our transaction map. Say Transaction map. Also going to be mapped from, right? And then we can just use the method group, I believe. There we go. So now we actually want to do, oh, and by the way, we need to actually always make sure that from the mapping point of view, that things are objects in memory before we do the mapping. That'll be, you will understand why. Maybe you already understand why now. Let's see. Dereference a possibly null as well. Yeah, I guess I could make that not null, and then we could say, okay, this class requires it, and so you must provide it like on the init, I suppose, right? Instead of like, I think that would be like an option. That doesn't solve the nullability though. But yeah, there is potentially like what happens if this is null. So we can say person map, you know, well, never mind, because it's a mutable property. But we might have some default. So we actually, let's say transaction map equals new transaction map, but it can be replaced with a different implementation or unit testing, right? And let's see, we have data entity map of, it needs to be, oh, what did we mess up? So it derives from the interface, transaction map derives from abstract class, transaction, DB transaction. And because I'm dumb, this should actually be transaction to transaction. There we go. Nice. Okay, so now you can see we don't actually have to have transaction mapping code in our repository now. Okay, so it's unit testable because in a unit test we can replace this property value with a mock, which means we can mock the entire mapping and return back what we want. But we are effectively now only having to focus on the person mapping itself. So this is much nicer. We're going to move that out into a separate class at this point. So let's do move type. And then we'll do the same thing for transaction map, which has a lot more mapping logic in. It's the data entity map. Let's go. Let's close all these files because it's getting a little unruly. All right, transaction map. Person map is what we want to work with. We do want our person repository. Okay. Okay. So now we have to deal with the transaction mapping. So have map DB transaction to transaction. So that's the read thing. We're going to take that down here. Okay, code style, data entity, blah, 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 blah. Get some nice formatting going on. I don't know how to type. I don't have all my extensions installed either. And now we need the transaction occurrence piece. Now, so there's some interesting things we can do here. We could continue building out additional mappers for some of these pieces. What I generally like to do, though, is all of this is logically related to each other, okay? Logically and relationally. So there's a balance, I think, of I don't feel a need to continue to create deep levels of mappers. I think this is fine because the main thing was separating out person from transaction. Okay. There's more to transaction we have to do though. So we have map transaction. Let's see, that was the data entity to the domain model. And you can see why this gets complicated too, because the names even are just over time, you start to lose track of like to data entity, main entity. Like it really just messes with your head after a period of time. Okay, so this method can kind of go away. We're gonna have some compiler errors because as we delete some of these methods, then the repository class is not gonna know how to do some of this stuff. We're gonna have to add it back in. We have the map into piece, so we're gonna go back to transaction. Now we're going to implement that, but first I think we're gonna rename this overload here. For this other piece, we're going to say map. What do we want to say? Map from data entity. So we need to kind of name it map occurrence from data entity. Okay. We're just kind of cleaning up some of the names so it's a little bit consistent. And now here we can identify very easily that, okay, the map from is the root of this particular map. And then as we find some named methods, we know those are more children mappings. So now we need to map. That's again, that's into the database. That all we had? That is all we had for the read, it looks like. Okay, so for the read, that's done. Now we're going to do the map into. So map into. Now we have map to and we have map into. So I don't think we actually need the map to. And I think I can explain why after we implement map into, because we don't really want to care about the creation of the data entity necessarily. There might already be a data entity loaded in the context. And if that's the case, we don't want to create a new data entity. We just want the one that's already there. But we do want to create new data entities if we're adding. So in the case of add, that does exist. But I think we can still get away with just from the mapping perspective. I think we can get away into map into. And then I think there's some logic that we can add to the repository class to handle the life cycle of actually creating a new data entity. So I think in this case, we don't want a base call because there's really nothing. It's going to throw the not supported exception. And so now we want to take the map into piece for transaction, and which was from, or sorry, we need to go back to the map transaction into DB transaction. We probably should even start with the map into for the person, which trying to remember, don't think we quite had because we just had update. I don't actually see. I think this just inherently was the top level piece that did that. So we are going to address this though. We are going to like, yeah, oh my God, we have to address this whole thing. So for now, let's do the mapping into of the transactions. We're going to take basically, you see there's a lot that it needs. User, basically the parent, which is the person, and the domain entity. We're going to have to clean that up. Let's move this whole method for now. And that means we're also going to need this guy. So map from, map into, so let's put those there for now. And you can see we also need, context. That gets interesting. Right, because we're handling the life cycle stuff now. So let's start with just easy pieces. Let's kind of organized a bit. Okay. So data entity, map into data entity. So what are we missing? Map into. We don't have access to the domain entity, right? So we actually are going to need an overload for that because map into actually needs to take both. So let's go back to our data entity map base. And so map into actually needs to be map into the data entity, the domain entity. And we could do it the other way around. We could say map the domain entity into the data entity, right? So let's go there. Map into this AI support. Sense, love it. Action map. Don't have it here, so this will be action, right? And we can actually just rename that, but I'm just going to go ahead and go just for click. entity type. There's a user in there somewhere. I'll figure that piece out. So again, user would be like the person, right? But I think in this case, it was the, oh, we moved the code. DB user is really interesting. So we could do, yeah, that gets weird. That gets weird. App into data entity. Assuming data entity already has. So we might have to rely on maybe navigation properties to an extent. So we're going to rewrite this for now. Data entity, sorry. Ooh, that's interesting. So we may not have, let's see if I had built it, iTransact. Is there an interface? Oh. Normally what I like to do, oh, well, duh. Transaction is never going to have it. So let's do, ooh, that gets weird. That gets really weird. Yeah, I can see. All right, we're going to come back to that. That's a weird one. We're going to have to do something like navigation property or get it from the data entity, that piece. And we also are going to have to do transaction type mapping. Which was all this was already done and working. So basically just grab these two properties because transaction types and occurrences are needed by the mapper. But what we'll probably do is make these dependencies. So that way the mapper is not responsible for loading them, which would be really awkward. We want the repository to be the thing that controls the actual querying and translation, and the mapper is really just A to B, B to A. So in that sense, we're going to actually put that code back here for now, just so we have it somewhere. But in the transaction map, we are going to actually say those properties are there. They need to get populated at some point. So we'll do transaction map constructor. And then for now, what we'll do is we'll put new, well, it's new dictionary string ints. These are kind of lookups. For now, at least those are there. Okay. And again, they're in the transaction map. So that we did the parent level stuff. Now we have children. So basically, like in this case, if a transaction does not have an occurrence, or like if they do an update operation, then the occurrence becomes null. We would want to remove that occurrence from the context, mark it as set null. And I think this is done through join table. I think is how that's happening. I think there's a occurrence. Yeah, so occurrence is the lookup table, and the transaction occurrence is a join table that joins a transaction to it. That probably could have just been transaction occurrence ID on transaction. I'm trying to think of why that was a join table now. I think it was mainly to separate out the columns on the tables to keep the tables really small, I think is what that was done for. Because you don't always need the transaction occurrence. Okay. Been a while since I've worked on this code, so going to get a little tricky, but basically if see, this is mapping into a data entity, so that's persistence. Transaction entity, transaction occurrence. Not null. So if it's not null, that means there's a join record, right? And we remove it. So why are we removing that? Actually here, setting it null. Ah, okay. So this is where mapping gets tricky. So we're always removing the transaction occurrence. And then whatever old record was there anyway, gets removed. And then a new one gets assigned. So here's the domain entity. So we can go ahead and move that code and preserve it for now. But we do need access to the context, which we don't have at all in these mappers. And that's probably going to be pretty common because as we're mapping these things, we do have to mark things for deletion or mark things for add. That is inherently going to be part of the mapping. So, and marking's easy because keep in mind, guys, that marking is doesn't actually do the commit, execute the queries and the transactions, the DBMS. So, yes, we do need reference to our context. So we're going to go ahead and couple this using a constructor. We're going to we know what our context is in our data model. So this will be, I think it is just database context. Wow, I'm being really stupid. Struct our, there we go. Then we're going to do database context. So that's in the base class now, which means we also now have to provide base class structure calls. But now we have access to the context to do the marking of the DB entries under the hood. Data entity. This needs to be main entity. Right. Data entity. Data entity. The main entity. Data entity. That one also is data entity. There we go. Nice. So that code is structurally as it was before. Okay. And that also means no, we need to go to person map. Context. And again, like this is interesting because we are assuming that the mappers are being executed within the lifetime of the same unit of work, right? If it wasn't, that would be a pretty severe design flaw or a bug. Okay. I think those were the two maps we had. So basically we have the map from transaction done, sort of, runs from data entity. And we have the map into, because reading is much simpler than putting it back, clearly. There might be a better way to do this, but in this case, the primary key in the database is irrelevant. It doesn't need to live for a very long time at all. So this is okay. It's an extra delete call when it changes, but it should run pretty fast. So we're done with this. And now we need to rename this guy. So we're going to, again, just for consistency. So we had map into for transaction. And we did map from, where's the map from? Oh, map occurrence from. So we'll do the same thing here. So this one's going to be map transaction, right? Transaction occurrence. Oh, this is the into. Map transaction Let's do this way. App into data entity, right? We will come back and revisit these methods, clean them up. Maybe we're starting to see the value of actually a third mapper hierarchy, because we're already seeing this code gets kind of ugly. This could just be a call to another mapper, basically. We might actually end up breaking that out. Now, if we go back to our person repo, we're going to we might want to do that. So person. Okay, so here we need to add the transaction map. We have a person map, person repo. Yeah. Okay, so we actually need to use the mapper on the repo. So how do we want to do this? Because we want to replace this with the call to the mappers that we just built. I think what we're going to want to do is simply public. I'll actually be above. I like alphabetical member order. So we're going to have, because again, we want this unit testable. So we're going to do the interface definition. So we have a person mapping to a DB user. This one's for the repository. And obviously there's going to be a default, be the person map. Passing in our unit of work context. Okay, so now in the find by user, this whole call here, for example, map data entity, which we can, oh, that was the base class, right? So the base class is no longer going to provide a mapping method. So we're going to remove that from the base repository. Just for clarity for the time being. And looks like we have some base logic for find by UID. So we're actually going to have to fix that up. It would probably be a good idea to have a default mapper on the repo, actually. So let's take map property. Let's actually put it in the base. Would make a lot of sense. There's no default at the base level, though. Like we could say, we could put a mapper constraint up here where tmap is new. We could create that tnew in the constructor. So there's default, but we're going to defer that up here for now. So we're still going to have the assignment of the default map here. So it's an implementation detail, but that means like for the base find by UID, now we can replace that with map from data entity, right? And then there's our data entity. I got that right, DB user. But this will actually be, oh, sorry, I think I'm being really dumb, right? Oh, yeah. T domain entity, T data entity. There we go. So now we're using our new mapper in the base method, find by UID. Okay, so now here, that's inherited. We have a different method, find by user, which is basically doing user ID. That's fine. So that's the actual data. We have a domain class called user, apparently separate from person. Interesting. And person might derive from user. Or other way around, I'll bet. Let's see. Nope, kept them separate. Okay. Kept them separate. So anyway, we're going to map from data entity, user entity. Right? So again, here's an example where the data model is the same. We have a DB user, but we have two domain entities that are structurally different. We have a user as a name and an email. Okay. Maps from the user table in the database. And then we have person also mapping from the user table in the database, but as an aggregate root looks entirely different, right? So again, that's why your domain model should intrinsically be different than your data model right there. If I could highlight that one moment and make a point of it, that would have been it. So All right, so what do we have left? We have, this is all specific code to the repository now. That's fine. We have all the updates. Messy, messy, messy. But here we have some loops. So I want to eliminate the need to write any kind of for each construct in these, period. This is a nightmare because every repository class you write, if you had to write this, like, no thanks. I've done it. I don't want to do that again. So we're going to come up with a better method to do this, which means something like we need the ability to call some kind of like map multiples. So on this person repository, we have, for instance, the map read model done. Now we need the map into for person, it looks like. So map override map into person is what we need now. And so now we need to take this code and holy moly, this is going to be a little nasty. So we're going to take, now to do this, we actually need to really truly move this into the base class data entity map, not in here. And then we're going to have to generalize the code actually. So that's interesting. It's going to be something like a collection. What's that going to look like? It's going to be like a map mini. Data entity. Right? Because if we're in the person map, and like let's say we have like map from, again, reads are nice and easy. This is just like entity framework plumbing, basically. How to mark them as added or removed or making the modifications. Okay. Design fun. So base class map, root level objects intrinsically may have children. Meaning, look at how this is actually being mapped. So basically we have added, so like given a person domain entity who has transactions, a user has transactions, right? That's the database table. That's the domain entity. And then we want to look for any new transactions, meaning transactions that are on the domain entity that don't yet exist on the user entity, assuming this has been loaded from the database properly. Modified transactions where the IDs match, and then remove transactions where the domain entity no longer has those IDs, but the database entity does, and it marked for deletion. So this can certainly be generalized because most of the methods for entity framework apparently provide generic type parameters for us to do this. Like add takes a generic type parameter. This is implicitly inferred as DB transaction right here, but it could be like T. Collections can all be type T. So I almost want to take this entire blob of code and say something like map T into, and then we have to say like what kind of collection is it going to get mapped into, right? Because it's the navigation property of the entity, I suppose. So it may not even be Like we can mark them for added or whatever. We want to wire up all the entity framework relationships properly as well. So I think we're going to take all this code, go back into person repos, and pulled that from the update method. Now, an update method would be something like, map into, right? So we load the user entity from the database, and then we want to map the domain entity into that data entity, right? And so we have everything to do that. So it's person and a user. So like that's calling the mapper or a update operation. That's really all we want it to be. Because we want the mapping to kind of do everything else for us. Think of it like a tree hierarchy, parent child, walk the tree. So we want the mapper to do all the mapping calls. We want the repo to kind of be stupid. Ultimately, the end game of this is the repo is effectively going to be the thing that primarily exposes the query operations, right? Find by user, find by email, get list of users by XYZ criteria. That's really what the repos are going to be. Also controlling the exact query. You could argue that the mappers have that concern. So this idea of controlling how children entities get added and removed from the context is really a mapping concern. So same kind of thing. So so we need to go basically into data entity map. We have person map as well. So we would want to map, like we actually need the map into for person first off. Map into, because that's where that code would normally go, right? Here's the map into for person, basically. If I was to paste all that in and swap the references. So let's do that. Let's actually let's just move this. Let's put it here for now. And we'll move it up the inheritance hierarchy here in a minute. Or 10 seconds. Okay. So base is just going to throw a not supported exception, but now I think we do want a base implementation for map into. That doesn't really do anything unless there's something to actually do. But the base is not going to be able to assume that there's children. That's something that is really known by the specifically defined mapper. Because like data entity map, okay, it's T going into T, A to B. It doesn't know that either A or B has children in it. So I think we need to provide support for child entities. And we can piggyback off Entity Framework's navigation property support. It's going to be a map into some degree, but it's not going to quite look like that, though. So we need to provide support for it. So if we were to think about it, it would be something like map any into data entity or something like that. Right. And then the mini would be, yes, it would be an enumerable of domain entities. We want to map many child domain entities, which isn't going to be T domain entity there. It's going to be T main entity here. We're just going to complain about that because it's hiding the type parameter, the parent class. So, maybe it's like T child entity. Main entity, right? And we want to map that into, and we need to know where it goes. So it's going to be something like INearable of T data entity. That's kind of what this is going to look like, I think. So I think that code, all this, really going to go there. There's our looping constructs. But how do we then know? Oh, well, these are the, okay, domain entities would be here. So it'd be domain, this is hard coded. So this would be domain entities there. Data, this would be data entities, replacing the specific access. So again, we're at the base data entity map. And yes, we also have to know something about the identity of each of these two. So we have to solve that problem as well, because it doesn't know what the identity of any of these are. Right? That's again, that's a whole other mapping concern. And then we'd have to rename a lot of this stuff. So let's rename it. We can basically say like, let's just do like new IDs, old IDs, like so. This will be T child data entity. We'll have to add some generic constraints, or we can do context. If I'm thinking entity framework 6, there was a create method that would create proxies. Doesn't look like there's a create method here. So we'd have to do new T. I think there's a proxy package, if I remember right. I'm using it. But we'll have to solve that as well. So for now, we can basically add that, say where T child entity is new, and solve that problem. This would be T child domain entity. And this would be domain entities. Again, we're going to have to solve all the ID issues. And I'll just say added IDs. We're really generalizing all this code. Yes. The added IDs. Oh, and modified IDs. Moved IDs. I really should install my extension. You know, we're going to solve that real quick. That is driving me absolutely bonkers. Driving me bonkers. So we need a line assignment. DevLabs, thank goodness. Oh, what a drag. At least I get a sip of my coffee. Okay, modify. And wait for the paint dry. This will go much faster. I have a Intel i9 processor, 13900KF. It was affected by the Intel microcode issue, and it's actually damaged. So the system runs stable, but I have to disable Intel's turbo boost, which means that the processor frequency will never run over the base frequency of 3 gigahertz. So I'm losing out on like literally 3 gigahertz of performance. Really sucks. All right, so let's load this back up. So basically, it gives me a Control-Alt, right square bracket, hotkey to do code formatting, which is like must write clean code. Okay, there we go. We're back where we were. So we have Tinu. Let's see, we have all our old IDs. Let's wait for it to catch up. Do we have any compiler errors? Yes, we have lots of them. Okay, map transaction into, so we don't have a, what are we doing here? So it's like for each ID in added IDs, then we basically should be tiled. Is data entity. Modified ID is tiled data entity. Okay, so that's pretty generalized at this point. So we still have the ID issue. And what are we doing here? So this is the child mapping issue. Right. So how would we know map if we map main entities into data entities? That would depend on a whole other mapper to do it. This into this. We need a mapper parameter for the children. A generic. Hey, that might be the case. That might be the case. Because otherwise, how else do we know to call the mapping for the children? Right? It's kind of what we want to do is like back up in person. We kind of want to say map mini. Transactions into the data entities navigation property. Right? That's the beauty of this when we get it all done, is all the way at the top level to add mapping for children. We just add a line of code. And then all the way up at the repo, like it's so simple. Map the person, map these children, right? And then no matter how many children there are, like we could keep doing it. You know, if there were different, you know, assets map into, now in this case, it's transactions as a catch-all. It's all transactions. It's assets, income, investments. So it's always to transactions. But if they were split out into different tables, instead of the data entity dot transactions, it was data entity dot assets, then all we'd be doing is continually adding these lines of code. And so from a test driven development point of view, each one of these methods, the actual mapping could be mocked out because the person map would have this other mapper that could be replaced with a mock. And so it becomes really easy to do mappings. So this is how this needs to be, but there's something about this that's missing because we haven't told it. Like there's a transaction map, but we haven't, the base class doesn't know anything about it. So it's like, how do we, not in transaction map, person map. Sorry. I don't even know where I'm at. Data entity map. Map many into data entity. I feel like we must provide a mapping parameter so we can pass in the mapper that knows how to do it, unless we said something like, well, we could do it this way. No. Well, yeah. Yes. Yes. Okay, it's coming to me. We can tell the mapper to do it. So it'd be map. We need to put that at the interface level, actually, too, by the way. Good gravy. An ugly, ugly method signature. Or type constraint there. Okay, so I just wrote. Still feel like I'm missing something here. Because I want to do something like map. Domain entity transactions too. Right, that's kind of what I want to do. So now we're doing it through the mapper that knows how to do it. Kind of the whole point. That's kind of what that needs to look like. So the map mini would be from the perspective of not being a child now. It would be from the perspective of, yes, I think the issue, these now. Right. Some old school. I don't know a faster way to do that. T domain entity. Well, it's all. Okay, so now I think these lines non-generic. Why is it non-generic? T data entity. Oh, because we need to add a constraint. Propagate that up. A lot of framework voodoo here. Does not implement. Right, that goes away. Non-generic. Oh. Okay. Okay, so I think now. Oh, I really screwed that up too. That's T. Domain entity. Or did I mess that up? For each added ID, create a new. Yeah. This should be a T domain entity. Then map into. There we go. There's the add and the modified. I also messed up here. Sheesh. This is why we wanted map into instead of map to, because the creation of data entities is going to be done really not through the implementation details, so to speak. So now we have map into data entity, domain entity. Data entity, like so. And then removal's removal. There's no mapping to be had. So that solves it, actually. So now for person, we have the transaction map, which now is map any into data entity, like so. And then the base map into doesn't actually need to be there. Again, we're not doing anything. There's just, unfortunately, like in the map into per person, all we're mapping into is really the child entities. We're not updating anything about the person. Like if I was to add the name and everything in there, but that's really done through the user class. Name for a person might be immutable in this bounded context, I suppose. So that looks good. Define A, what is not satisfied? I have to add it to every single one. I don't remember. That would suck. Oh, we wouldn't have to add it to new. Oh. Where are we creating a new person, actually? DB user cannot satisfy the new constraint. Because DB user has required members. Oh. Right. Email in Entity Framework 6. So that's a problem. We can... I think that was needed. Yeah. I'd have to remember. We'd have to go back and look at the documentation for the nullable aspects of it. Because I think EF might have used the required keyword, but I'm not 100% sure. It's been a while since I've looked at this. I actually really dislike nullable reference types. I love the idea, hate the implementation. Glad it's an opt-in feature. Okay, but we did solve the mapping issue. So now all the way at person repo, again, we need to take care of this piece here. So we're going to get this code working so we can actually run the app and show that the read model works as well as the persistence model. Now, at some point, the transaction map or the person map has to have these guys on there. Which means we're going to have to pass those down even through the person map, actually. Okay. Let's go and remove that for now, just so we can get the code to compile. Go. All right, let's go look at... Okay, so the map must pass those down at some. So what we're going to do is basically say from transaction map, we could probably make these constructor parameters. Unfortunately, that gets a little tricky because they need to be loaded at some point, but they could be empty dictionaries, I suppose, as constructor parameters, but they need to be the same collection ultimately. So I think what we're going to do is down in transaction map where they're actually needed. I think we're going to could do it bottom up. So we could basically say these get initialized and then person map has access to those might be one way. So we could do something like let's copy these definitions. Go to person map, and then we can say like get transaction map, which I think is on the class an iData entity map. So we would kind of want to solve that, I suppose. So for now, let's do the other direction. So let's do their dictionaries, which gets really annoying. Yeah, dictionary string of int and dictionary string of transaction types. Maybe what we want is not the lookups. Maybe we actually want the data entities for these. So maybe we really want db occurrence and db transaction type by enumerable. Much easier problem to deal with. And then what was I doing? Oh, still through the constructor, what we want to do. So we have enumerable db occurrence, enumerable db transaction type, transaction types, right? So in person map, then still want to pass those down. Maybe we want to propagate them, but if it's going to get loaded in the constructor, though, we don't want to load them in the constructor. That is the problem. But again, they can be empty and loaded later. They just need to be the same reference to the same collection. So then all the way up in our repo now, like let's say, so here's where we're going to go ahead and get rid of those properties. So now this is much cleaner. Let's go ahead and say we already have backing fields for them. Well, so that's cool. Let's make those initialized though. Let's do high collection. So that resolves our issue there, but now let's actually initialize them. Be whatever. Let's just do a list. I suppose we could do transaction types like so. So basically we initialize our backing fields to new lists, and then we pass the reference of those lists down to the map, and the person map will pass it down to the transaction map. So during the construction of the classes, they'll be empty, but it'll have access to it. And so then we just have to make sure it gets loaded before any of the mapping happens. And so that could be something like this is all specific to the person repository access, by the way. So we can say something like when find by user happens, or when update happens, we could actually say, and we'll actually share a method. So we'll say like private void load, dependent, let's say load dependencies, just for lack of a better name right now. Then let's say occurrences is equal to context occurrences. We'll grab so that's going to fire off a query. And then we're going to do the same thing. If I could type correctly, but I don't know what I'm doing, apparently. And actually, we do not actually want to, we want to clear. Sorry, I'm being really dumb. We want this to happen once. We're going to say if occurrences count 0. We don't want to continually load things more than necessary, right? If it's used in a unit of work and we do multiple calls to find, we don't want to constantly be querying for occurrences. Okay. So if they haven't been loaded yet, then we're going to then actually add, and it looks like there's no add range. There wasn't add. Let's actually make this list then. I think we could do, like, can we do iList? I don't think it matters. Yeah, so let's just do list. Pretty sure that has add range, and then we're going to do context occurrences as enumerable. Okay. We'll do the same thing for if action types count 0. And we're going to do literally the same thing. Okay. And now we're going to do right before the mapping, so we can do a little bit of an optimization. We don't have to actually, load dependencies, and then probably also there as well. We could probably add a null check to the update method, because like this is coded to throw a invalid operation exception, which is fine because it's like, hey, we didn't find the entity for the person you're trying to update. So here's an exception. We could throw a better exception if that was null than invalid operation exception, right? Now find by user returns null because that's the nature of a find operation. Update is a little bit different. So anyway, we'll leave it for now. But now we're loading the dependencies, so they should be present. And so I think the only thing left to solve now is the identity issue in the base class, because the data entity map base does not have any context of what the UID or ID is. Now, I think we can actually do some inheritance. I have a DB entity. Everything's going to be by UID, I believe. That's partly why I added it. So UID is effectively a client ID. It can be generated by the client or by the server or by the database engine, but it effectively is the equivalent of the primary key. It's just not an int. So that way our database design can use ints, which are much faster for joins and indexing and things like that, but we still have the UID for lookup. So it effectively is kind of like a primary. It could actually be the primary key. We could just make this the primary key, whole other video, and then change this to the, clustering key. You just don't want your GUID to be the clustering key. Okay, anyway, different topic for another day. So we do have DB entity. I think all these derive from DB entity. If we go look at our model, we have DB transaction, occurrence. So let's go under data entity map and let's actually change the type parameter from data entity to DB entity. It's really interesting. But if that's the case, then we would also need something for domain entity ID. I don't know if we have a domain entity base class. We do. So let's change. So it's not T domain entity, it's DB entity and main entity. Which means that these would not need generic parameters then. Okay, so it would be domain entity, DB entity, right? And domain entity using domain. DB entity is still, yep. It's non-generic, so we don't need the constraint now. So let's change all these to the entity and T domain entity becomes domain entity. Look at that. We have beautiful compiling code. Let's go up the chains. So let's go check transaction map. Don't need the type parameters. Ooh, yes, we do. So we actually, sorry, we do. We do. That was a mistake. Sorry. My goodness. So we need, yeah. All the way at the interface. Where T domain entity is domain entity. And where T data entity is DB entity. That's what we needed. And we need to propagate that up. Okay. And then we need to add those constraints to that as well. Copy those because I'm super lazy. Interface. Where is our interface? I closed it. Data entity map. Constraints. Like so. Does not implement interface member. Oh, I guess we do still need to add the... Oh, if it's a new DB entity, though. Oh, well, I guess it needs to be both. Right? Got to be both of T data entity and new. There we go. There we go. That's looking much better. All right. So I'll fix these up because these aren't dictionaries anymore. So I think we're getting pretty darn close. Okay, we're just going to replace this for now with a single. And it was name, type, and transaction type ID probably. Yeah. Yep. There's our other compiler error. So again, occurrences, single, where probably going to be, looks like time unit. Looks like we're grabbing the whole object practically. Occurrence ID. I was going to return. We want the occurrence ID by. Oh, that's probably an enum value. So it's going to be name is equal to the enum value name. And then we want occurrence ID. Okay. I think that takes care of all that. I think we might have a building project again. Let's see. So we're looking at so far about hour 45 minutes for a pretty large refactoring. So we've basically, oh, nope, we got 4 errors. Let's fix these before I get too carried away. So, okay, hang on. No suitable method to override. Map data entity to domain entity. This is it. Oh, sorry. We haven't done the whole other repository class is what that is. So we'll come back to that. And then looks like we have some issues here as well. So this actually needs to be DB repository. Looks like we need to add probably some generic type constraints here where T domain entity is domain entity new. That satisfies the map property, the interface. And so now we just need to fix up our other 2 repositories, it looks like. Yeah, so close all. Let's start with the simple one, which is our user repo. So now you're going to see the really cool value of this is we can go to our user repo. And let's see, down here. Well, we haven't introduced mapping for the other two repos, I suppose. So we would need a user map as well as a occurrence map, right? So let's write those really quick. And then we'll also have to figure out where the maps are going to actually exist. So we actually have data entity map, person map. Yeah, so we're going to probably create like a mapping folder, I suppose, and put all these in here. We might even, so it's basically, there's like this mapping layer, I guess, that's tightly coupled. So the data layer is tightly coupled to the domain layer because of mapping. So we might even move that out into its own project, potentially. But for now, let's go ahead and add them. So let's just go to the repo. Looks like we need to add all of our constraints. I don't have resharper, so it's not going to do it all for me. Go person map. Repo. Oh, we didn't have to do it at the repo level. Where do we have to do that? DB repository. Satisfy the new constraint on T data entity. Swear we just did that, and I'm probably blind. Oh, DB current has required members. Sorry. Okay. Yeah, we're gonna have to figure out the required piece. We're gonna have to come back to that. Probably the same for implicit reference conversion from financial occurrence to domain entity. If we have that backwards, so T data entity, main entity. I'll fix the overrides now. So okay, all right. We need a public class occurrence map, data entity map, occurrence, DB occurrence. Right, actually, I think it's DB. Yeah, it is DB occurrence. Okay, so implement the map. All we have to do is the read map. So we're going to take the old mapping code, plug that right in, fix our names, delete that override, not necessary. We are going to add our mapping property. So it was from occurrence, DB occurrence map. We're going to initialize the default. That's going to take a context as a parameter. Database context. That's a base class call. Like so. Oh, I finished typing it. Okay. What else we're missing? We have to add the, again, I don't feel like we don't, we're really going to have to fix all these. At some point. What's it complaining about? Cannot be used as a type parameter G, main entity, or in the generic type or method type. There's no implicit conversion from occurrence to domain entity. So what is occurrence? Value object. It is a value object. Well, so that's interesting. So we might consider occurrence a value object that does not have an identity right now. So if it did, it would be name, effectively. So we will have to solve that too. Okay, so let's finish as much as we possibly can finish anyway, for now. So we have the new mapper, same error, probably for the same reason. And looks like we have, we're now going to say as enumerable before we map, execute the query, we got to map based on objects, select, and now we're going to say this is a occurrence map from data entity, method group, actually. Okay, so we can copy that down here. So query where, want the where to hit the database engine. Like so. So we fixed up our occurrence repository. Let's put this guy in its own file. Oh, fine. Fine, Visual Studio. Don't be nice. There's an error, and let me do that. Occurrence map. Please do file scoped. Thank you. Okay. All right, so this repo now for the occurrence repo looks pretty good. Minus we need to correct the error for value objects. All right, and then probably the same thing with the user repo, actually, because again, we don't have a user map either. So we're going to borrow from occurrence repo, just syntax, because I'm super lazy typing that out. And this will now be user, db user, map, new, will be a user map with context, public class user map. We'll borrow from that as well. All right. Base context. That looks good. From database context to database. Sure you can. Namespace issues. And this will be actually, here's our user mapping here. So that's an add. Find by email. So here's our mapping. Map from data entity. Entity. User. Data entity. User. There's our user map. Okay. Map. Wow, scoped namespace. Okay. All right. User repo is solved. So I think now 40 errors. Good Lord. Okay, 3. Just updated. All with the occurrence repository and occurrence map because they have the same issue, which is occurrence is actually currently a value object and not a domain entity. So the question would be, I suppose we need to be able to read value objects from the database. I suppose that's the issue. So that's going to be back in our data entity map. So this kind of implicitly assumes that, okay, if we're going to map into many or map into, there's some kind of identity value. So these constraints up here are kind of bad in the sense that they assume domain entity. So maybe what we could do is basically create a base class that is not type constrained to domain entity possibly. So maybe we do data entity map T something. So maybe this is more like T object, T data entity. So let's do, and actually let's call it let's call it T data entity. Right? And that means the interface would also, have to do that. And the interface is also constrained. But that's kind of problematic. So there might need to be potentially an interface as well, or maybe the whole thing could be an interface, actually, because if we think about it, there's not going to be a lot of base class logic for mapping value objects. So maybe it can be an interface. So let's actually go here and see if we can do this where it's idata entity map t object t data entity. And then maybe we can say t domain object like that. But they look exactly the same. So that's not quite what we want. We want like the names are problematic now. So for now, this is like the most terrible thing you could do is call it base. Okay. But we need to move all of these into the base, except for probably like the map intos don't make sense. I mean, they could, I suppose, like if you're mapping, it's really a T object. I guess the value of this interface is it type constrains everything. But maybe the issue is it doesn't make sense for this interface to exist, because could we even do this without this interface? So let's go to our map class. And if we were to derive or implement rather, I suppose we can still type constrain it at this layer. And therefore we don't really need that other interface at all. So it's just an object at this point, and then we seem to have a specific implementation. But then maybe higher up in the chain now, the mapping properties would have to be possibly the concrete type. Let's see, person repo, map. Put the map at the base class, it looks like. The DB repository assumes, well, the base class, but then DB repository really shouldn't have these constraints on here. But I think we can get rid of those since we effectively are not constraining this interface. But then we have like, okay, find by UID. Well, that really only makes sense in the context of a domain entity, right? So that base method probably is used in a bunch of places. Maybe if we're lucky, not. So let's comment that out for now and see if we can come back to it. Maybe find all references on this guy. So maybe we'll get lucky. Okay. And so let's just check each of our repos. See. Oh, that's a diff. Let's see if we can build. Currents repo. Key domain entity. So I think now we need to. I feel like I'm missing something on this occurrence map. We're doing T domain entity. Oh, this was the value object. So this is going to be the interface now, right? Really? Yeah. Base. Okay, is that it? That might be it. All right. Well, we're building. That's a plus. We don't have any guarantee that anything is actually going to run. Let's do the smoke test. Because why the heck not? So obviously this is either going to, fork and fail over or not. Okay, so the dashboard right now has some issues. I need to fix that. So that's going to fail as normal. So when we go to the income screen though, would you look at that? It did work for the read model. So let's debug through that because that's a really cool refactoring on the first try. So if we go person repo, let's go, we'll just go find by user, I guess. Probably should get hit on every page load. Okay. All right. So we have a domain user. So we're in the person repo. Okay. Dependencies get loaded. So at this point, it's a unit org. So the occurrences and the transaction types, again, remember these are just lookup tables. So those are going to get loaded. And only once for the lifetime of this particular repository. So there we go. We have 5. That's great. That's awesome. Transaction types, we have 5. That's great. That's awesome. And then, oops. Now we're going to map the user entity, and you can see they've got 2 transactions in the database. Okay. We're going to map it to a person. So now if we step down into the mappers, so here's where we're actually going to map the transactions. That's enumerable. It'll be a little bit deferred until they're accessed, I suppose. We probably could do like 2 array on that so that the mapping happens right away. Might happen at this point. Transactions already has 2. It looks like it did already get enumerated. And there's our person with 2 transactions. That's awesome. That is totally awesome. All right, let's make sure the persistence works. So again, smoke test. So let's add new transaction, $10. Let's go ahead and exercise some of the other codes. So let's do frequency of 1, put an end date, December 2nd. Actually, let's go like 19th, whatever. And create. Oh, all right, we got a first error. So here, occurrence is 5. No matching element, so the lookup is failing. So we have date of month on the time unit. Or name. So it needs to be time unit and not name. See if we can hot reload that bad guy. Oh, look at that. Nice. Okay, we got another fail. So we have a foreign key constraint. Let's see, invalid column. Or on the column user ID. And that's going to have to do with, we'll have to check that. So let's see, this was an update. That should have rolled back as part of the unit work. Yeah, so we'll save the entities to the inner exception. Looks like we need to make that better as well one day. Oops, flat. All right, so let's go step through the update API then. Try that again. So keep in mind, this is the mapping into. And so probably we do have the right user, data entity, and the domain entity. So we can see the ID 9B33, UID 9B33. Yeah, so let's navigate into that guy. Let's see where the hiccup is. So probably Obviously, there's an added ID. That's the new transaction we're trying to add. Yeah, so there's our new $10 transaction we're trying to add. So 10 has an occurrence with an end date of 19th every day of the month. Okay, that looks good. And then so we have the mapping. So the mapping should map the data entities. So we have same thing. And there's our UID and a 0 transaction ID. Now, what's going to happen with that is Entity Framework will auto-populate that value. Save changes is called. So we're doing an add. Technically should work. I did add. Got some modifications. Make sure it's not trying to reuse the same transaction ID. So there's transaction ID 1. Transaction ID 2, that looks correct. Okay, and there were no removed IDs, so that all looked correct. So I have a feeling where we messed up is having to do with the navigation property piece. So we're basically saying map this collection into this collection. I feel like that something missing there. So let's go back, look at that code, because we add it to the context, but do we ever manipulate the navigation property of the entity? Probably not. Because we would want to add it, but also populate the relationship. With the parent. More than likely. Because otherwise, Entity Framework is not really going to know. Let's let that run. Oh, we probably want to actually let that fail and then run because we manually stepped over the code a few times. So like if we add data entity, does it have a reference to the person? Yeah, okay. So we have not solved the tying it to the parent record for the database side. So that piece is going to have to be solved. So that's an interesting one. Okay. Because so it's trying to add it, but it doesn't know what the heck it belongs to. Okay. Stop. And we got to figure out where we're going to do that. So like in this case, go back to our data entity map is where that's going to matter. So I feel like the way I've done this before is at the person level, where we map all the transactions. Somehow we need to tell it this is the user ID that they belong to, especially for created ones. So the question is, do we need to pass in the parent? Actually, probably. I would love to do it here, but it does need to be done, I think, in here. We go to the implement. Thinking we need the parent domain in. It'd be like T parent. But at this level though too, it doesn't know what that parent is either. The problem. We have the domain entities. They don't necessarily have a reference to their parent. almost do like a property expression passing in the parent. Yeah, so if it's T parent, how do we do that? Have the parent here. Third parameter. T parent. Because it's almost like we want to do like map this domain entity into this data entity. Oh, well, I see. So we probably want to go like transaction map, for example, and then we have like map into. We still don't have the parent though. It's like the creation of the filed. Yeah, I think we need to. Okay, so I think what's going to happen is when we call map for the children here, we intrinsically have the parent entity here. This is the navigation property, actually. So to tell entity framework that new transaction entities belong to this parent user, this parameter, I think, needs changed to a collection. So we can add it to the navigation property. So I think this becomes collection. And then like for an add, not only can we add it to the context, but we can tell it that the new data entity going to get added to that. And I think same thing here when we remove it from the context, order doesn't matter so much. We need to remove it from the navigation property because removing a data entity from the context just marks it for deletion. Adding it marks it for add. It doesn't automatically wire up the navigation properties. So by doing that through the navigation properties, Entity Framework is automatically going to manage the foreign keys in the primary key relationship. Let's rerun that. See if that does the trick. And then for an update, nothing changes. We do have to update the interface, so that's going to be iCollection. And then that would probably be something that we document on that method later. We actually have to do it here as well. So let's see, data entity. Oh, so what did it actually build? No, one failed. Is it hiding the error from us? Being dubious. Occurrence map. iCollection. Okay. And I still want to do something better for the value objects than having to re-implement the interface. That's really unfortunate. But value objects will probably not have children. They're probably standalone, immutable values. Okay. Oops. Wow. Okay. Just be able to click create. See if that magically works this time. All right. Refresh. Make sure it persisted. And there you go. So we did the add. We've got the read. Let's check the updates. We're going to change new transaction to something more like our awesome new transaction via fun design changes. $100. I will say on the second mirrored model. We'll just per second, click update. Oh, and okay, past transactions. Okay, that's there in the UI. And yes, Cool. All right, so we accomplished both goals. So you can kind of see the magnitude of the changes. We had 15 file changes to get everything to work. That we had, so new iData entity map interface, data entity map class, and implementation of that in all the repos. But now let's go back and look at exactly the change. So if we go person repo, but look at all the implementation details that we were able to remove from the repository class out into effectively 2 or 3 different mapping classes. Okay, so the repositories over time, as we add additional query methods, like right now we just have find by user, no big deal. And update is very straightforward. And maybe there's custom update logic that needs to happen at some point. That's kind of the point of the repositories, is to encapsulate access to the data. But we've separated the mapping concerns. And so anytime we change our database schema, now, not only do we update our data model, but we can also update the mapping. Does not necessarily mean the domain model changes. We can change the domain model. Does not necessarily mean that the mapping has to change, but it could. But now you can have independent changes in each one of those layers of your project. Often you're going to change all 3, but now they're unit testable because you can mock out for the repository class. This is really important. We can, for example, if we're unit testing person repository, we can completely mock out the mapper. So when we set up the unit test or find by user, update, load, all that kind of stuff, we don't have to set up the whole database hierarchy for a person and their transactions anymore. We can just mock the mapper and tell the mapper to do exactly what we want it to do, so we can focus on testing the repository. So if you think about it in the sense that, there was years ago, there was arguments that entity framework was the repository abstraction. And then it came to be that, with clean architecture, we actually want additional repository abstractions on top of that, because EF is doing what it does best, right? It's translating, it's being that object mapper between your database schema, giving you database schema objects. And it's handling the translation of SQL so you can write link, right? That makes things way easier. And it integrates with the language, okay? It doesn't need to really do more than that. And so the amount of work that it takes to do something like this, where we actually have another repository sitting on top of that, you can kind of see why now. It interfaces between that and your domain model, and your, really that and your application service layer, I suppose. But this is why we want these pieces separate. It's why it works so well. So there's a lot of pieces to make it all work. But again, going back to the original problem, when you really break it all down, there really truly is a lot going on. So if we're talking about single responsibility principle, don't repeat yourself principles, that all pretty much applies here. Okay. And then when we go down here, we get to the mapping, see how we made writing the code for mapping, all that code that we had, and those for each loops, we never have to write that again for a repository. It's abstracted all the way down into the data entity map. So that you would not want to rewrite this in every single repository that you need to create in your architecture every time you have a child entity on an aggregate root or multiple, which gets really ugly, especially when they're layered. Because if you have a parent with children of children of children, and maybe that's a very complex aggregate root, but maybe there's a use case for one like that, you do not have to write this. This is done. It's one and done. And it takes care of, as you saw, it takes care of everything automatically. So, all right, we did that. And that was like 2 hours and almost 30 minutes. I hope you guys really enjoyed this particular video. This is kind of one of those more, I would say, enterprise scale types of changes that you're building framework level code. You're going to reuse this code across your entire platform. This is really important that you have something like this. And I wanted to show how to do it. And we did that in 2.5 hours and got it all working, which was really awesome. Not with tests, but I have written code like this, or a very similar implementation to this that was fully tested. And I'm going to be looking at ways that this could possibly be improved, I suppose. But right now, this is pretty good. I think the next step would be to say, hey, can we improve this to not just work with domain entities, but say value objects? And then there are some other complex scenarios we did not talk about, like what happens when we do object inheritance. Like we have a person, but then we have derived types like employee, manager, that kind of stuff. How do we deal with inheritance in mappers? And maybe we'll save that for another video because we will have that use case at some point. So anyways, if you like this video, give a like and definitely drop some comments below.